So what you see on this sheet is a series of dots. They look something like this. At time 1, the object is located at this position. Then the lights go out, and the object moves. We don't know where it's going. And then, like a strobe light, the light comes on for a split second, and we see the object is now here at time t2. And the lights go out, and the object continues to move. We don't know where it is. And then the strobe light flashes for a split second, and now the object is over here. Okay? And a split second later, it's over here. And the key to these diagrams is that the strobe light always goes at fixed time intervals. Okay, so the time between these dots is always the same. So when you look at this drawing that I just did, what do we know about that motion of this object? Constant speed, right? And if I were to draw it a little differently, what do we know about this object's motion? Slowing down, because in the same time interval, right, time interval between point 1 and point 2, it moved 3 squares. Time interval between 2 and 3, which is the same, it only moved 2.5. So it had to be going slower, right? Okay. So let me pass out the worksheet, and then we will. You can work on it on your own for a few minutes, and then together, and then we'll talk about it. Question?
For number 1, are we supposed to assume that it's moving in one direction, like it doesn't go back and then move forward again?
Yeah. So what I did, I put the numbers there to indicate the direction. So if I had numbered it from right to left, then we would assume it was moving to the left, because the first flash we would see it on the right side of the screen, and this next flash it would be to the left a little bit.
I meant like during the motion, like it continues to move in one direction.
Well, what I would do is split it up a little bit. So, like if the object starts out moving to the right, like the object 2 here is going to eventually come to rest, and then maybe it's going to start moving in the opposite direction. Yeah, we'd have to be careful how we draw that. We'd have maybe you draw one line with the object moving in one direction and then a second line moving in the other direction so that it doesn't get too confusing. Because we're just talking about one-dimensional motion right now. But you could have that situation, yes. Okay, so for the motion diagram worksheet, question 1. Describe the motion represented by the diagrams. Constant speed. Okay. How does the time to generate the shortest diagram compare to the time to generate the longest? Same, because they all have the same number of dots, and the time between dots is all the same. Describe how you could use your answer to rank the diagrams by speed. Yeah, so speed, distance over time, right? They all have the same amount of time, so the one that covers a longer distance is going faster. Okay. How far did the object that generated diagram D travel in 1/20th of a second? 2/20ths of a second. 3/20ths. Okay? Because every 1/20th of a second it traveled the same distance, 3.5. How far would it travel in 1/10 of a second? One second. What formula do we use to calculate the speed? I just wrote it down, didn't I? Speed is equal to distance over time. What's velocity equal to? Okay, the difference between these two. One is a scalar, that's speed. It only has a magnitude associated with it. So if you're driving 55 miles an hour, that's your speed. If you're driving 55 miles an hour due east, then it has a magnitude and a direction associated with it. That's velocity. What's the difference between distance and displacement? Maybe you go for a jog. You leave your house, you jog 3 miles down the road, you turn around, you jog 3 miles back, you get back to your house. What distance did you travel? 6 miles. What's your displacement? 0, because displacement, you just care about how far this thing's moved from the beginning to the end. And you're back at the same place. No displacement. So you had some average speed the whole time you were running, right? But in the end, you didn't go anywhere. So your average velocity was 0. Does that make sense? We'll talk more about that. Okay, let's find the speeds. What speed is object A going? It's 3 centimeters divided by 1/20th, so 60 centimeters per second. And B, 30 centimeters per second. And C, 40. And D we did already, right? What do we need for a complete answer? Units. Right? All right, part 2. Sketch a possible motion diagram from motion where the speed varies and describe the motion. Why doesn't somebody just describe the motion? I'll draw it. Somebody describe motion of something at varying speed? Slowing like so a car, the light turns red, you hit your brakes, the car slows down, right? That's something with varying speed. So what would that motion diagram look like? Something like that. How do we know the speed is varying? Yeah, the distance between those dots changes, and those dots are equal time intervals apart, so therefore the speed has to be different. Let's do one. How about another one here? This is what is this? Is a car slowing down for a red light. Let's do throwing a ball straight up in the air. Something like that, right? Starts off with a big velocity pointing straight up, and then gravity starts working on it, goes slower and slower and slower until eventually it comes to rest.